Assalamualaikum and a very good day. Adik Profesor Mahir Taslim, Engineer Dr. Siti Asina binti Siti. My name is ELYASA, unit number 19458 with my partner SYAFIQAH. Today we present our advanced fluid mechanic mini project proposition, which is designed as of an open channel to a triangular web. So for introduction, a web is an overflow structure constructed from the individual to the active on an open channel to the discharge. It also a barrier that spans the breadth of the river to modify the flow characteristic of the water, particularly regarding the of the height of the river. So in the industry, the side of the wear can be classified by two, which is the side of the crest and the side of the nose. Crest is basically a device that permits the water to flow over its top. For the first two diagrams in here, it shows the different side of the crest that commonly used in industry, which is broad crested wear and the sharp crested wear. Broad crested wear have the soft point for the falling net over the crest, while the sharp crested wear, the sheet of the water frees as it departs the crest. For the side of the nose here, as you can see, they made out a shape egg plate with a rectangular for a rectangular wear and triangular or V-knot for a triangular wear shape to guide the water. So the difference between all the side of the wear is basically the usage of it. For the sharp crested triangular wear, commonly used for research purposes because they can measure the flow of the small scale open channels, while rectangular wear is commonly used for the large scale open channels. So these are the tasks given to us for our mini project, basically to design a twin plate wear, where the flow rate must be 10 to 15 meters per second, and the two horizontal sections 5 meter rectangular channels, and with the water depth remains less than 2 meters. So the size of the wear and the dimension must be designed, must be chosen according to the specification provided. Then prototype must be produced to demonstrate the design selection.
Hi, my name is SYAFIQAH with DEBAYAN, matrix number 198935. Now I'll continue the presentation with the objective of our mini project. The overall objective is to design and experiment an open channel with the selected wear type. Thus, the specific objectives are as follows. Firstly, the objective is to design and dimension an open channel with a triangular wear prototype. Secondly, is to determine the flow characteristic of a triangular wear. And thirdly, to compare water flow characteristic at different flow rates. So now I will justify why a triangular wear is chosen for our design prototype. Firstly, triangular wear can measure the flow accurately at a wide range of discharge rate, especially during the low discharge rate. So when during the low discharge rate, the water heat value over the wear is still greater and can be measured in comparison to the rectangular wear. Thus, when the water heat is larger, the effect of clinging net over the wear can be reduced.
For theory and calculations, we have three assumptions, which is the first assumption is the water pressure is constant throughout the channel. The flow of the water is steady and active laminar phase after passing through a heating bubble and under negligible frictional effect. So these are the common meanings for the flow rate of the sharp crested triangular wear, where the Q is the flow rate of the water, G is the gravitational acceleration, ED is viscous coefficient, and theta is the nose angle, and height, H is the height of the crest. Basically, all the information already given except for the height for the crest. For most practical purposes, the height is more than 0.2 meters, and the angle of the triangular is basically on the range of 45 to 120 degrees, and the distance coefficient is basically 0.58 according to Unit and John 2017. So after using this formula and fill up all the numbers, then we get the height of the crest 2 meters.
The specification of our design is finalized based on the limitation and the part that is needed for our prototype. There are three main limitations that is outlined in this specification, which is firstly the building material, which is we use corrugated plastic board is not capable to firmly withstand water pressure. That means that when the volume of water is large, the material will start to bend outwards. Secondly, the flow method that is available in the chemical process lab has a calibration range up to 18 liters per minute. That is very insufficient for the given design data, which is up as much as 12.5 meter cube per second. And lastly, there is no functioning water pump, so we have that we take an alternative, which is to only adjust the water tap to manipulate our flow rate of water. The design prototype includes steering baffle, which is this. This is the steering baffle, functions to ensure the laminar flow of the water. The wear plate we designed using a triangular type and a 90-degree angle for the simplicity of the design. And lastly is the channel wall for sides and the rear wall.
For experimental procedure, we are ready to prepare a video, so hope you enjoy it.
The result of manipulating water flow rate, as you can see here, at the low flow rate, medium flow rate, and high flow rate, you can see the obvious difference between the three results. Now I'll discuss what we have obtained from our result. First is the type of flow regime. In the low flow rate, it is called clinging flow regime. The medium one is called bistable flow regime, and the high flow rate is called free flow rate. Why is it called that way? Because water nap appears to cling to the wear plate at low discharge rate, which is at the lowest rate. At the clinging flow regime, the water nap will cling to the wear plate. Thus, when we increase the flow rate, it will cause the water nap to spring from the wear. So this is what it means by clinging nap, which means that the water flows down immediately and hit the plate of the wear. So as you can see from the result here, when at the lowest rate, you can see the water cling to the plate. But when we increase the flow at the maximum rate, you can see like none of the water cling to the plate, and it just shoot forward, far away from the plate. Okay, since we cannot, due to the limitation in data, we do not have sufficient data, we have decided to find a theory in comparison between the three flow rates, which is the coefficient of discharge. Coefficient of discharge coefficient is higher at clinging flow rate, which is at a low discharge rate, but it will oscillate in bistable flow regime, but it is negligible in free flow regime. In conclusion, water flow rate includes the determination of water characteristic over the wear crest. Greater flow rate causes water to shoot further away from the wear plate, thus resulting in a more accurate discharge flow rate. Discharge coefficient value that is based on the literature. That is all from us. Thank you for listening.